Hello 8th graders. In this IXL support video we're taking a look at assignment F3 called Solve Equations with Variable Exponents. So this is still building on our understanding, our knowledge of exponents that they show us repeated multiplication, but now it kind of becomes a math puzzle as they ask us to solve these equations. And the first one that we're given, it says 3 to the power of q equals 27, or they're really saying 3 raised up to what power. Let me rewrite that. They're saying 3 raised to what power, I'm going to put a little question mark, will give us 27. And the way I do these problems, I say, hey, if my base is 3, I'm just going to start by working through this. What's 3 times 3 going to give us? If I had 2 of those 3's, that would just give me 3 times 3, or 3 squared would be 9. But if I multiply by another 3 now, 9 times 3 gives me 27. And that's the answer we were looking for here. So there must be 3 total copies. 3 times 3 is 9. 9 times another 3 is 27. So that tells me, hey, q here must be 3, because 3 cubed, or 3 to the third power, will give us 27. Our next question here says 7 to what power equals 49? So I'm going to just start writing out 7 times 7 as many times as I need to get to 49. And when I do 7 times 7, right away my answer is, with those 2 copies of 7 multiplied, I get 49. So that tells me my answer here must really be 7 squared. 7 squared, or 7 to the second power, is the same thing as 7 times 7. For the next example that we see here, we see it's 6 to what power? 6 to what power makes 36. In the interest of time, I think a lot of you are at home saying, hey, the answer must be 2, Mr. Doherty, because 6 squared, or 2 copies of 6 multiplied together, would give us 36. Now feel free to pause this video if you want. You'll be thinking about 10 to what power makes 1,000. And there's a couple ways to do this. One way, you could multiply things out. 10 times 10 isn't going to quite get us to 1,000. It just gets us to 100. And then if we multiply by one more copy of 10, 100 times 10 does get us to 1,000. So there are 3 copies of 10 here, and I could say 10 to the third. But I want to point out a little trick here. Whenever I multiply by 10s, however many 10s I have tells me how many zeros I get. 10 times 10 is 100, and you see 2 zeros attached to that 1 when I did 2 copies of 10 together. So if I want to get to 1,000, a 1 with 3 zeros, I know I'm going to need 3 10s. 10 times 10 times 10 will make 1,000. And that helps me out here a bit. Here, how many 10s do I need to multiply together to get 100? A lot of you are going to say 2 right away. That's great. You could also see the 1 has 2 zeros attached to it, so that must mean there are 2 10s multiplied together. Either way, we're getting there. The reason I pointed out those tricks is I don't want to keep multiplying out all these 10s to get huge numbers like 100,000 or 1,000,000 or 1,000,000,000. Here I see there are 5 zeros attached to that 100,000. 100,000 is a 1 followed by 5 copies of 0. And that really means that this came from 5 copies of 10 multiplied together. So I'm going to save time. I'm not going to keep writing out times by 10 to get to 10,000, times by 10 to get to 100,000. I know there must be 5 copies of 10 to create a 1 with 5 zeros attached to it. We're going to skip ahead. At this point, you have everything you need to do very well on F3, we believe. So feel free to pause the video and go do F3 on your own. I'm going to skip ahead and show a couple more challenging problems. Okay, so it looks like when you get to the 80s, they'll start to throw a few trick ones. The first one that I see here that looks challenging, or a little more difficult, they're saying 96 to what power equals 1? And a lot of you are probably saying, well, Mr. Doherty, if we just have 1 copy of 96, 96 by itself, 96 to the power of 1 is still too big. It's going to make 96, not the 1 that we need. And this is where it's important to remember that anything to the power of 0 equals 1. So in this case, 96 to the power of 0 is 1, because every number applied to the power of 0 is 1. We're going to talk about that more in class and why that is the rule and needs to be the rule in math. This one wasn't more challenging. It's the same problem we did earlier. Why it's up here in 83, I don't know. Okay, 3 to the power of c equals 243. And so some of these, I think you're just going to have to go ahead and multiply stuff out a lot. I know 3 times 3 is 9. I know 9 times 9 is 81. So that does tell me that 3 to the 4th power, if I did 3 squared and 3 squared multiplied together, I'd do 9 times 9. That would give me 81. And now I'm a lot closer to 243 if I do 81 times 3. 3 times 8 is 24, and that's where this 243 comes from. So 5 copies of 3 to get to 243. Taking a look at the challenge zone just to see if anything gets a little bit more difficult there. But again, we believe you don't need to still be watching and you should be good to work on this on your own. It looks like for 90 they just get more challenging. Powers of 2 are helpful. I can do 2, 4, 8, 16, 32, and one more is 64. So if I do 6 copies of 2, that gets me up to 64. Here they're building 10 to what power makes a million, and if I see 6 zeros, there's kind of a bit of a shortcut here. If I see 6 zeros attached to the 1, that must have come from 6 powers of 10, all multiplied together. Again, another problem that makes you remember, anything to the power of 1 always equals itself. So 10 to what power would equal 10? It must be an exponent of 1 because we just have the base term and nothing else with it. Last example here we're showing, I see 10 million again, 7 zeros attached, so that must be 10 to the power of 7, and I don't know why IXL repeats problems on you so often. Thank you for watching to the end of this video. We think you're in awesome shape if you've made it into the challenge zone. Keep up the great work.